All right, let's talk about one of the most famous and honestly most controversial patterns in all of software development, the singleton. It's a tool that promises incredible power and simplicity, but just like a double-edged sword, if you're not careful, it can cause some serious damage to your codebase. So, is it a legendary weapon you should have in your arsenal, or is it a dangerous relic we should leave in the past? Let's dive in and find out. Okay, so what is it really? The core idea is actually super simple. One, and only one. That's it. The singleton pattern does two things. First, it makes absolutely sure that a class can only ever have a single instance. No more, no less. Second, it gives you one single global way to get to that instance from anywhere in your code. To make this really click, just think about a country's government. Right? It doesn't matter who you are or where you are in the country. If you need to deal with the government, you're dealing with the same single entity. It's the exact same idea in software. And this is fantastic for managing some kind of shared resource. Things like a single connection to a database for your whole app, or one configuration manager that holds all the settings, or maybe a logging service. So how do we actually make one of these things? At first glance, it looks pretty straightforward, but like any finely crafted tool, the details really matter, especially when you need it to hold up under pressure. It's really just a classic three-step recipe. First, and this is key, you make the constructor private. Why? So nobody can just go and create new instances whenever they want. You're locking it down. Second, you create a private static variable inside the class. This is what's going to hold our one and only instance. And finally, you create a public static method, usually called getInstance, that everyone has to go through. This method checks if the instance has been created yet. If not, it creates it. If it has, it just returns the existing one. This whole approach is called lazy initialization, because we don't bother creating the object until the very first time someone actually asks for it. Now, here is where our beautifully simple pattern can completely fall apart. In any modern application, you've got multiple threads running around. So what happens if two threads call getInstance at the exact same millisecond? Well, they both check if the instance exists, they both see that it's null, and they both try to create it. And boom. Suddenly, you have two instances. Your one and only rule is broken, and all sorts of chaos can break loose. To fix this, developers came up with a really clever, if a bit complex solution called double-checked locking. It's all about being safe without slowing things down too much. Here's the dance. First, you check if the instance is null, just like before. But if it is, you don't create it right away. Instead, you enter a synchronized block, a lock that only one thread can enter at a time. Once you're inside that safe zone, you check again. Now you might be thinking, wait, why check twice? Well, because in the tiny slice of time it took you to get the lock, another thread might have gotten in, created the instance, and left. That second check makes sure you don't create a second one. It's a bit of a brain twister, but it makes the singleton thread safe. Okay, so we forged a powerful thread-safe tool. We should be good to go, right? Well, not so fast. This is where we flip the sword over and look at its other edge, the dark side that makes so many developers argue you should never use it. Ouch, that quote is pretty brutal. But you know what? It really gets to the heart of the problem. Many experienced developers will tell you the singleton is actually an anti-pattern. An anti-pattern is something that looks like a good solution on the surface but ends up causing more problems than it solves. And why? Because that single global point of access is just a fancy way of saying it's a global variable that any part of your code, anywhere, can reach out and touch. And that creates a hidden, tangled web of connections that can become an absolute nightmare to manage. Let's break down these dangers, because they are very real. First, it violates a core principle of good design. A class should only have one job. But a singleton is doing its own job and managing its own creation and lifecycle. That's two jobs. Second, it creates what we call tight coupling. Other parts of your code become directly dependent on that one specific singleton, making your whole system rigid and hard to change. And testing? Oh boy, testing becomes a mess. You can't easily swap out the singletons for a fake one, a mock, during your tests. So you're stuck testing against the real thing, which might be slow or connect to a real database, making your tests unreliable. And this isn't just theory. It has major real-world impact. I mean, just look at the giants. Companies like Netflix and Spotify, which operate at a mind-boggling scale, actively avoid patterns like this. They found that having a single global instance of anything creates a bottleneck that just can't keep up when you're handling millions of requests a second. In the modern world of distributed systems and microservices, the very idea of one single anything becomes a huge liability. But you don't have to take their word for it. Let's look at some cold, hard data. Check this out. Someone actually went and measured this. A study looked at 100 open source projects and measured something called type coupling, which is basically a number that tells you how tangled up and dependent the different parts of the code are on each other. And the results were just wow. Codebases that used singletons had, on average, more than double the coupling. That's not a small difference. That is a massive, measurable hit to how flexible and easy to maintain your code is over the long run. So, if the singleton is so full of traps, what are we supposed to do? Is there a better way to get the benefit of a single, shared resource without all the problems? Absolutely. Let's talk about the modern path forward. And that better way is a technique called dependency injection. It sounds a little intimidating, but the idea is actually incredibly simple and elegant. Look at the code on the left. The creature class has to actively go out and grab the global map instance itself. It's hardwired to it. But now, look at the right. Instead of the creature fetching its own dependency, we simply give it the map it needs, maybe when we create it. The creature becomes a passive recipient. It doesn't know where the map came from, and it doesn't care. It just knows it has the map it needs to do its job. This tiny shift in thinking is unbelievably powerful. And the benefits are just huge. Your code becomes loosely coupled and flexible. Testing is suddenly a breeze because you can just pass in a fake test map and see what happens. The dependencies are crystal clear. You can just look at the constructor and see exactly what a class needs to work. Best of all, you get the exact same result. You can still use one single map instance throughout your entire app, but you do it in a clean, controlled way where the application itself is in charge of wiring everything together, not the individual classes. Okay, that was a pretty big journey, from forging the singleton to seeing its dark side and finding a better way. Let's bring it all home and recap the entire story with a quick mind map. So here's the whole story in one place. We started with what it is, that simple promise of one instance with global access, which seems so useful for things like logging or configuration. Then we saw how it's made, with that private constructor and static getInstance method, and the tricky business of making it thread-safe. But then we uncovered the dangers, how it's really an anti-pattern in disguise that doubles your code's coupling and makes testing a nightmare. And finally, that led us to the hero of the story, the alternative, dependency injection, which gives us everything we wanted from the singleton, but in a way that leads to flexible, testable, and just plain better code. So here's the bottom line. The singleton pattern is incredibly tempting. It often looks like the easiest and quickest solution to a problem. But as we've seen, its long-term costs to the health and maintainability of your code are very, very real. So the next time you think you need one, just pause for a second and ask yourself this question. Now that you know its power and you know its peril, when will you choose to draw that sword? Because more often than not, choosing the more flexible, more testable path of dependency injection, well, that's the real sign of a master developer. Thanks for diving into this with me.